In this ANSYS tutorial video, we will be looking at Lab 3 question number 2. Before we get started, we first have to determine which units we're going to use in this question. Looking at the example, the SI column, the table of consistent units, would be our best option. Therefore, we're going to have to convert all of our centimeter values to meters and all our gigapascal values to pascals. Next, we can go ahead and determine which type of element we're going to define in this question. And looking at the model, a solid element type would be our best option for this question. As well, we're going to define it as being axis symmetric as well, because this model is symmetric about the x-axis here. In terms of material properties, we're given elastic modulus here, Poisson's ratio, as well as our thermal expansion coefficient, which will all be entered in later on. To create our model, we got to keep in mind that axis symmetric only works in the y-axis. So if we're going to use this feature, we're going to have to rotate the model so that its symmetrical axis is aligned with the y-axis, like so. Another thing that stands out to me is that this model can be cut in half and is symmetric about this axis here. With that in mind, we can come up with a general shape of our model, which will be essentially this top right quadrant here of the pipe. In terms of meshing, it is not specified in the question what our mesh length has to be, so it is up to your discretion to pick a mesh length size. In terms of constraints, we have a full body constraint up here with 0 degrees of freedom, which is this line right here in our question. As well, since we're cutting this model in half, we're going to have to keep in mind that there's a symmetry body constraint here at the bottom of the rectangle. In terms of loads, there's a thermal drop of 20 degrees, so we're going to have to specify an initial temperature and a final temperature in ANSYS. So getting started, we can go ahead and open up ANSYS, and under the preprocessor tab, we're going to create our element type. So we're going to click on element type, add, edit, delete, click on add, and we're going to create a solid model, 8 node, click OK. And since we want it to be axis symmetric, we're going to click on options, and under K3, we're going to specify axis symmetric. Click OK, and we're going to close that down. For material properties, we're going to go under material properties, material model, and structural, linear, elastic, isotropic, and we're going to enter in our elastic modulus as well as our Poisson's ratio. Click OK. Now we're going to enter in our thermal expansion coefficient. To do that, we're under the structural tab here, we're going to open up thermal expansion, secant coefficient, and isotropic. And here it prompts you to enter in your thermal expansion coefficient, which is given to us as 17.3 to the power of -6. Okay. Next, we can go ahead and create our model. So under the modeling tab, create areas, rectangle by 2 corners. And looking at this diagram here, we're going to start off 0.15 meters in the x-axis and 0 in the y, with a width of 0.1 and a height of 1.5. Click OK. And now we can go ahead and mesh our object. So we can close down the modeling tab and open up meshing. Click on mesh tools. And we're going to set the element attributes. We're going to set the area to have all the properties we defined earlier. Click OK. And we're going to set the size controls. So under areas, click set. Click on our model, and I'm going to choose a value of 0.01. This is an arbitrary number. I just did it to split up the model 10 times along its width. But once again, it is completely up to you in deciding what you want your element length to be. So we're going to click OK. And once again, we're going to go ahead and mesh our object. Click on area and OK. And we should get something that looks like this. Now we can go ahead and apply our constraints to our model. And from our diagram, we know there's a full body constraint here at the top with 0 degrees of freedom. And at the bottom, there's a symmetry body constraint. So under the Solutions tab here, we're going to open up Define Loads, Apply, Structural Displacement, Symmetry Body Constraint on Lines. And we're going to select on the bottom line here, click OK. And we're going to also create our 0 degree of freedom body constraint, so displacement on lines this time. And we're going to click here on the top, click OK. All degrees of freedom, and remember to enter in a displacement value of 0. Click OK. And now we have a model fully constrained. Now it's time to apply our loads. The loads this time will be applied in the form of a thermal change. So under the Define Loads tab, we're going to open up Settings. And here it prompts you to enter in a uniform temperature and a reference temperature. In ANSYS, the reference temperature is our initial temperature, and our uniform temperature is our final. So since it's a 20 degree drop, we're going to set our initial to 20 degrees. Click OK. And we're going to set our uniform temperature to 0. And I just picked these two numbers because it's a 20 degree drop, but you could go from 40 to 20 or something to that effect. So we can go ahead and close down this tab, and we can open up the Solve tab, click on Current LS, and go ahead and solve our model.